In my experience, NFTs and blockchain technologies in general get very mixed reactions among developers. While there are certainly enough horror stories to make anyone skeptical about all things blockchain, I am certainly of the opinion there's a very real future in this space, and overlooking it as a developer would be a mistake. But how do we even go about designing a system that will run on a blockchain network of some sort? Here to talk to us about NFTs and architecture design for blockchain projects is someone we're very grateful to have at ETE and is another talk I'm very excited to see. Room C has been great. Lead author for NFT standards, ERC 721, and Ethereum blockchain developer, William Entriken. Welcome, William.
All right, hi everyone. So I'm Will. I'll give you a little bit about myself before blockchain and then tell you about some of these projects. I like the opener. I really appreciate that, Jack, because there's definitely mixed reactions, and especially if you lump in NFT with other stuff. So just a quick background on me. I'm Will Entriken. I've been involved with blockchain since 2018, a few years now. My background in engineering is I started my career in open source with Google and worked at the South Philly Navy Yard. Some other local stuff, I've worked on computer research, breaking into things, red team, is basically what I do is find problems with security, web, front, back end. One of them I worked with the FBI on related to some banks. If you ride public transportation, I also help contribute changes to the SEPTA schedules. That's something I do for fun. And a recent engagement I had was with EY locally, where we're working with NFTs for supply chain. So just to talk about what is blockchain, what is NFT, I hope you know what some of that is by now, but just to kind of separate it, blockchain is a lot of things. It's Bitcoin, it's Ethereum, it's things that you buy and sell trying to get rich. They're basically all worth nothing. All these blockchain things are basically worth zero, and they'll probably be illegal at some point. So don't lump me in with people that think that Bitcoin's going up, Bitcoin's going to zero, Ethereum's going to zero, everything's going to zero. So this is not going to be like an invest in stuff. NFT happens to run on blockchain, happens to run on Ethereum and other stuff. And I'll even be the first person to tell you don't use NFTs. So my background here is I got involved with Ethereum because I saw an opportunity to standardize something, and it's called ERC 721, also known as NFT, also known as non-fungible tokens. And right now it happens to be very popular for artwork, but it has a lot of commercial enterprise use cases. It's just a couple of them, working with a government in Mexico to track COVID test results using NFTs. And that's a slightly contrived use case. I mean, we didn't have to use NFTs. They really wanted to use it, so that's fine. But the real benefit here is that you can't forge them. You can't forge the test results. You can't backdate them. And that was a very big problem in Mexico. So this is something we solved. Obviously, there's a lot of artwork. If you've read anything on the news, that happens to get a lot of press attention just because the art, people are making a lot of money on that, and newspapers like to carry money stories. But otherwise, I'm working on a lot of enterprise use cases, and you are too. So welcome with me here to talk about some enterprise use cases. And we're engineers here, right? So I wanted to get into architectures for these type of projects. So if you're going to be building some type of a blockchain or enterprise NFT project, what would it look like? Now, again, it was kind of weird. I dropped a hint, like, I don't even need anybody to use NFT. Specifically, you don't even need to use blockchain for a lot of your projects. A lot of the things that are coming out that are using blockchain really don't need it. It's okay to use it. I mean, it's just extra infrastructure and buzzwords to maybe help you with some press releases, and FOMO is a real thing. But otherwise, these concepts that we're learning here and the discipline that we're getting from applying blockchain to a company, to a product or something, that's critical. And so you can use these things that you're learning here to understand architectures for other projects, and you can get the same benefits of blockchain without using blockchain, which is like, that's the real win. So the people that are going to win the most from this presentation today will be, if you're doing a blockchain project, that's great. If you're working in a government or any other type of public, transparent type of thing, or a nonprofit where you have things that you're publishing stuff, you want things to be authentic, you don't want there to be any question of what you're publishing. Government by default is public. Government by default is transparent. Everybody's salary is public. So there's no privacy in government, really. And so government is a natural use case for blockchain, because blockchain, everything's public, everything's transparent. So Whether government is using blockchain or not, I really don't care. But these concepts that apply to the architecture and the product design for blockchain totally apply to government, totally apply to other systems that are like that. Also, there's other use cases for very large companies for supply chain. Some things are public. Another good thing that is very valuable in NFT and the blockchain ecosystem is that it prevents fraud. These tokens that we're creating, they don't get stolen. Nobody's stealing tokens. They're tricking you. I mean, there might be like you might be tricked into selling your token at a low price. That's trickery. But nobody's stealing your token. These things are secure. Nobody's copying your token. Nobody's questioning that if you have a token, is there like, do you have it or does someone else have it? There's none of that. There's no duplicating. If you have a certificate of authenticity on blockchain, there's no question. It's real, it's authentic, and it can't be copied. So things that have certificates of authenticity or you need to track specific things, these concepts are great too. So to discuss this architecture, I wanted to talk to you as a project planner or as a, you're a project manager or you're an architect, and just look at some of the things that you might run across. And to start this presentation, we'll go through some past architectures from the very beginning, from the 80s, from the 70s and 80s, up into modern web, which is pretty complicated. And then we'll break that down. We'll start over with blockchain, and then we'll talk about how do these pieces fit together for blockchain. And then we go into some specific things for blockchain, some kind of gotchas and stuff like that. These are this is what will really save you a year off of your project. These contingencies, these things you might not expect. Because a lot of people think, oh, there's Web 2 and there's Web 3. Some people call blockchain Web 3. Like, well, Web 2 and Web 3, it's like, well, that's just like the same as HTTP 1 and HTTP 2, right? It's the same thing, you connect it, that's kind of scary. So Web 2 and Web 3 are very different animals, and they shouldn't have such a similar name. But yeah, so we want to look at it this way from the different pieces. So let's get started. Mainframe and web. So this is pre-web. So before what we call the World Wide Web today, we had clients. These are thin clients. These are, they're going to connect to a mainframe. So this concept might seem outdated, but actually this is coming back. Pep Boys users are used to use this. They still have thin clients and mainframes in the Pep Boys. This is a, hey, right, a quick question. Is this, I'm sorry, Jack, quick question. Is this Philly audience, or what's our audience, like our geography here?
It's mostly like engineers, I would say, and people who code and that type of thing. So
geography?
Oh, geography. I'm so sorry. That is actually a good question. I would assume that most people are probably from the Philly area, but
no, that's cool. I had a few Philly references throughout here, but I wasn't sure if I was talking to like Asia and Europe or whatever.
No, I was gonna say I feel like it's mostly Philly. Yeah.
That's cool. Hey, everyone in Slack, if you got two screens open, just say where you're from in Slack too. Love to know. So yeah, Pep Boys, strong Philly car company, car maintenance, which obviously had a big change lately. They stopped doing retail; they just do maintenance now. But they still use this. So don't think that client and then mainframe, client server, this client mainframe, thin client mainframe. You don't think this is out. So what's really going on here? When we say thin client and mainframe, what does that mean? Well, why do we do this? Well, the mainframes are really expensive, and so you had to buy time on them if you were going to do a mainframe, or if it's something you would dial into like a console or a virtual terminal, which is what Pep Boys does. Is they have basically a thin screen, sort of like Citrix or whatever, but they use Linux. All the processing is done in one place. So there's a few benefits to that. One, it's completely consistent. You're not going to have transactions come in and then not be consistent, because when the transactions come in, they're all settling on the same place, and the application and the database are together. And so really the thin client is only responsible for the display, putting the pixels on the screen. Back in my Navy days, we had a mainframe connected to a printer. Like the application was literally just a printer, and it would just spit out PostScript. Same thing. Also, all the things were done in whatever the place where the application ran, and it would just spit out PostScript directly plugged into the port, and it would spit out papers. Have fun debugging that. But if you ever wanted to debug that, and this system was very dated, but it still works, so nobody got rid of it. And if you want to fix that, you would fix it on the server end, and then think of how many signatures you need to change something like that. So has anybody worked on these type of applications? Is anybody still using thin clients out there? Is somebody still using mainframe thin client architecture? I mean, it might not literally be a thin client. It might be something like a Citrix or RDP. I've seen an application where they use RDP, and there's a host provider where they have a whole bunch of RDP instances. They were run by the service provider, and then the clients would log in with RDP, remote desktop, and then access their applications that way. Citrix, RDP, they're very similar. There's other ways you can do this. You could shell in BBSs. If you ever used BBSs back in the day, that's what was going on here. You would dial in with your modem. These are not dated. I mean, all these ideas are old. So, it might seem not popular today, but we will come full circle back to these type of applications someday. So let me know if you've done anything like this. So here's the web applications. So this is the basic web. How does Build work? So now we call them hosts. So we have the OSI model. And so the host does presentation, not just display. So presentation as a concern includes painting pixels, style sheets, localization, maybe. It might include responsive. So the same application can be delivered for desktop, but it might look different depending on if your screen's big or small. That's responsive. So that's presentation. And then the application is on the server. Now, for most of the web, the application would be like Cold Fusion, PHP, Node, whatever, and it's spitting out HTML, and lots of the HTML is dynamic and it's changing based on whatever's in there. And that's cool. And as the future's coming, we have more JSON or REST. We have more types of media crossing the line. It used to be a lot more HTML, CSS, JavaScript, that's it. Now we have data coming across. And the database is on the other side of the application. This is the normal web model. So this is where the database is behind the application. The host doesn't touch the database. This stuff should be obvious to you, but all this is going to change in Web3. So I really want to spell out these puzzle pieces and how the host does not directly touch the database. There's an application, there's access control. And the databases, we have something called eventually consistent. So there might be multiple databases. This might be horizontally scaled, vertically scaled. We think of web scale. So there's going to be lots of nodes out there. And as long as you understand what needs to be consistent, you'll probably be fine. And then we have CDN, so content distribution. So this could be media files. The media files aren't really part of your application. Your application kind of delegates access to the media on CDN. CDN could be images, assets, it could be profile photos, it could be videos. But those videos, basically we think of CDN as stuff that's not going to change. Like Netflix video. When you load a Netflix video and I load a Netflix video, it's the same video. In the future, that'll be, we'll have different, even if it's Bandersnatch, it's the same video. The same stuff is coming onto your screen and it's parsed a different way. But also for Comcast. So Comcast, they have their own cloud, and so they have their own content distribution. And so you pull those things from the local loop. Kind of mixing network topology and the way the servers work, but that doesn't matter because we're architects. We don't care about layer 1 or layer 2. Okay, so the bits and bytes for the bulk of our stuff could be on CDN, and it's not really changing very much yet. And then the application's kind of over there, and the application's more about who has access to stuff, things that you're writing usually go to the application, and the application puts it on the CDN. For example, you might upload a profile photo, and then that, back in the day, you could kind of shove an animated GIF into Twitter, and then you would have an animated Twitter profile. That's because they didn't validate their inputs. They kind of just pasted it right on CDN. Well, that's the wrong way to do it. Instead, the application should read your bits and bytes and then probably reformat it or resize it or whatever, compress it, and then it goes on CDN. That's why when you upload your profile photo, it's kind of like, oh, this could be a few minutes. And you're like, a few minutes? Yeah, because you're in a queue and it's going to resize it and it's going to compress it even if it's a little bit of compression, they want to compress it as best they can, shove it in CDN, publish it to the world, eventually consistent. So also there's so the host in the modern web, we also think about machine learning and some, I'm not a buzzword guy. So when I say machine learning, I mean machine learning. So we're also talking about AR, augmented reality. So right now, if you have an iPhone and you open up Safari and you go to the Apple website, some other websites have it, and you click on the product, you can point it onto your wall and it'll show you what whatever product looks like on your desk or something. And it's using obviously the range sensors in your phone and all that stuff to composite the view on your screen. That's done locally. So this is a big difference compared to mainframes, because all the processing is done locally. There can also be some privacy done locally. For example, differential privacy. This is not really popular today. Apple does a little bit of it. There's some other frameworks that use differential privacy. But in that case, the decision to send logging events or whatever other private information is done on your host, locally, and then it's given to the application in a way that the application doesn't have a full picture of what you're doing. So there's more agency in the host here. On the other side, we have surveillance, also known as IoT. This is basically all the things that have microphones in your house that you don't think have microphones, including your thermostat, which has a microphone, and all these things. And so they typically don't have a direct connection to the internet, thankfully. Still, what they do is they go through some device in your house, such as your HomePod or your something Alexa, and then somehow it ticks into that, drives into that stream, they connect to the internet. And so if this was a good ecosystem, these devices there'd be some type of a firewall. And so like your Alexa device would not share 100% of the stuff coming out of your microphone with the internet. But in the modern web, basically these things are just meant to spy on you. So they probably just send everything directly to the mothership. But in the future, you might think of some device in your house, which is going to maybe do some machine learning application locally to determine if this needs to go out. For example, Apple Watch does this. So Apple Watch has a microphone, and if it sounds like there's breaking glass, it will detect that on your watch and your phone, and it won't send that directly to Apple, that sound. So the sound is processed locally, and then some concern is sent. It's none of Apple's business what the breaking glass sounds like, but it might be somebody's business that you want to call 911, that there's some broken glass. So some processing is done locally, some processing is done remote. More things come locally because batteries are better and processing is cheaper. And then we have lambdas. So lambdas are short-lived, specific, probably RESTful, probably like a specific input gives a specific output. Lambdas have a much broader definition, but you might think of them as something that has a specific input and a specific output and can easily scale at any size. They're nice for queues. So you can have, this is the profile photo example. So the profile photo comes in, we've got to scale it, we got to compress it, we got to check for inappropriate stuff in there. This can all be done in a Lambda, in a queue. And I wanted to show it in this picture as connecting the application to the CDN. Because this might be a unidirectional thing. It might be coming from the application to the CDN. Okay, I think that's as much as we need to talk about for the modern web and all the pieces. Now we can start talking about blockchain. So blockchain's got a few special things going on that are just not really intuitive. So I want to kind of scare you, bring these things up and talk about first, what is blockchain? Like what type of things are here? So basically, you can think of a blockchain as a notary service. You can think of it, you can call it a lot of things, but the way it works is it notarizes documents, it notarizes transactions, it notarizes authenticity, it notarizes availability or removal of resources, tokens, stuff like that. One of the use cases for NFTs includes these pictures of cats. It's all about the cats. This is one of the first very well-known applications, Cryptokitties. And so one way of saying this is you might say blockchain is really just a certificate of authenticity of who owns these pictures of these cats. You also got DeFi, decentralized finance, which is not actually decentralized. And you might think of this as money. You might not think of it as money. But if you think of it as money, then you can consider blockchain as just certificates of who owns these money. So they're kind of more like depository certificates, and you can track them. It's nice because, again, the tracking is blockchain is very good at tracking stuff. It doesn't lose things. Forgery is extremely expensive. And if there ever was a forgery on blockchain, you would know, because there's trillions of dollars riding on this stuff. And if you were going to forge something, would you forge like something not substantial, or would you forge like an extra $1 billion into your bank account? So, or how about $1 trillion or $1 quadrillion into your bank account? So when that happens, that'll probably eventually get reported on the news. And if you don't hear about an extra $1 billion going missing, then you can assume that people haven't really hacked Bitcoin yet fully. Identity applications. So applications like I was telling you with my government in Mexico, it's Quintana Roo is one of the states there, and they endorsed this application for COVID testing. They also have micro-credentials, or some schools are now doing transcripts or diplomas, not entirely on blockchain, but you get like a physical and then a computer, like a digital one too. It's kind of a novelty application, but other types of identity include membership in a group. So you could be part of a group, and then you could receive some type of blockchain certificate, token, something. Proof of attendance. So you go to an event, they give you a token, thanks for participating, and you can prove you were there. So these are kind of a novelty too, but we're early. So in the future, these could be really fun to have, really valuable, really rare. Those are some of the use cases I wanted to highlight. Blockchain is also a database. So you can think of it as a notary, think of a database. So how's the database work? This is more like Ethereum. So Bitcoin, maybe not so much as a database, and you can maybe hack it or really imagine it that way, but that might be rough. But Ethereum, definitely. Tron, things that are similar to Ethereum, basically they're all just Ethereum copycats. Ethereum is a big computer that takes these transactions and tracks account state going forward in time. So it's a consistent database where you track account state for a bunch of different accounts. And so you can think of it as a database. So the database is ACID compliant. So that means you've got atomic transactions, they're consistent, and they come in, they settle in some order. It's Turing complete. So it is a Turing machine. So any application you could write on there, but you wouldn't, because these applications are extremely expensive. So blockchain, you can run a lot of stuff on there, and people are generating pictures in the blockchain. They got Bored Apes, they got pictures of monkeys that they're selling for a lot. And they've got other things that are similar to that. And some of these pictures are generated on-chain. We say on-chain, that means that the application is running in the blockchain. And it's really expensive. So typically what we want to do is we want to minimize the application that's running on-chain, and we want to move as much responsibility as we can off-chain. But the parts that you do want to put on-chain are Turing complete. It's eventually correct. So you may hear of eventually consistent. This is different. Eventually consistent means the transaction goes and it will get there eventually. Blockchain is worse than that. Blockchain, you could send the transaction, it could settle, and it could settle wrong. And then, you give it a few minutes or 15 minutes, and then it might settle differently. So you're like, well, you said it was ACID compliant. Like, what is that? Well, yeah, over long periods of time, it is eventually ACID compliant. ACID is something you can water down. Anything can be ACID compliant if you water it down enough. And base, acid and base, you can water down. Combine them, they're water. So eventually correct means that your transaction that you think settled may or may not settle. Now, one of the security guarantees that blockchain has is that eventually the transaction that settles, if it's going to settle differently, there's a very high cost for changing that. Now, just the way the blockchain works, there's different people competing to make blocks and to settle transactions. And there's just this economic game that basically you want to not be contradicting other people, because that gets expensive really fast. Like thousands, hundred thousands, millions, billions of dollars expensive, just super fast. And this is also why, if you've heard of a 51% attack, that's how expensive it is. We've studied the economics of this stuff. We know it really well. And sustaining an attack, if the value of hacking your transaction is here, and you know that the value of sustaining attack more than 30 minutes is here, then you just assume that there's no attack and that your transaction is settled. That's why if you've used blockchain, if you've ever tried to withdraw your tokens or something, they'll tell you, like, wait a few minutes. When they say wait a few minutes, what they mean is you're trying to withdraw $10,000 worth of things. And if you wait a few minutes, it would cost you $1 million to trick us into getting away with that 10,000 and us not having the 10,000 securely. And they're like, yeah, $1 million for 10,000 doesn't make sense. So they let it through. That's basically a whole course of blockchain in that one bullet there. Hope that makes sense. But here's something you definitely understand. It's $20 to store 1 byte of information. Yes. So like I said, these things are really expensive, and the bytes are, you got to be economical with these bytes. So you're not storing a lot of information here. $20 for 1 byte, I'm not joking. You do get a, buy one, get a few free. There's a discount, but that's the order of what we're talking about here. So when would you spend $20? Putting a COVID test result from Mexico on chain, is that worth $20? Might be. COVID test results cost more than $20. Is a picture of a cat worth $20 to store on chain? Absolutely. The pictures for cats go for a lot of money. So $20 is nothing. Are you going to install like a user profile on chain? Probably not. Probably not worth securing on chain. So there's different things that you would store or not store on chain. This is a critical decision for architects, is what's going to store on chain and what's not. So let's talk about the architecture. How would you build this stuff? So now we have something called a dApp. A dApp includes what's on chain, the blockchain stuff, and it also includes kind of your website, could tie into a website or some phone app or something. It's all one product, so we think of it together. Now, the agency concept is very strong here. So more important than having a host or a thin client, we talk about the person and their agency. And again, this is multiple devices. So this could be their browser, their phone. Really, when we talk about the holder, we're talking about somebody who has signing authority. Blockchain uses public key cryptography. And so whoever has access to that key, that's an agent. Now we have a static application. This is sort of like the CDN. And so different than Web 2 or PHP or Node, where you're serving rendered HTML to people, we're not doing that so much. We're giving HTML for the generic application as a whole. So everything on blockchain is public, so you're not hiding information from people. Basically, you're just loading one big HTML file or multiple HTML files, and then the data comes separately. Now the chain. On chain, that's the database. So all the data is public at all times. Now for Ethereum or something like that, everything's public. Maybe you have a different blockchain based on Hyperledger, and it's a consortium, and it's semi-private for multiple companies. Yeah, okay, but I still call that public. There's no data in that system you can't get. You might not be everybody can get it, but you can get everything in the system. That's also a critical design constraint when you decide what information goes in the system, especially if you and your competitor on the same system, which happens. Do you want them to know your sales figures? Do you want them to know your serial numbers? You can't really avoid some of this stuff. So in the future, we're gonna have more transparency, but I'm not the type of person who's gonna tell you, make everything transparent. Think about what makes sense. But here in this diagram, the person directly reads the data. Now this is a little fuzzier, there could be technology. This could be a browser connecting to an Ethereum server. This could be a human going on a completely unrelated website to verify data. This happens actually very frequently. This is a lot fuzzier than normal Web 2. And these can be happening, the person who's the agent here, the holder, they can access all of these things at all times. They can make a transaction with you and verify it on a third-party website you don't even know about. One of them is called Etherscan for the Ethereum network, for the ecosystem of Ethereum. So they can make a transaction with you and then immediately verify it on a different website called Etherscan. We still have an API, so there's got to be some way that data gets to you that's kind of not on-chain. It would be proprietary to you, which would be hidden behind a normal database. So this is the same type of situation going on here. But now there's a critical misstep here. There's two things that are not connected. Your application is this API here. I don't know if you see my mouse. So that's where you're making money. You are charging people access to your API. That's how you sustain your business. But a lot of the important stuff is on chain. So something's got to connect the chain to your business. We call this an indexer. An indexer is this unidirectional data flow that takes stuff from on-chain and puts it into your business application. And then also there's another thing where your customer, the agent, the one who has authority and agency for making all these transactions, might not actually have their own key in their mind or on their computer. They might use a hard wallet. So they have a physical device with their password on it, and nothing can happen without that password. So that's just another layer. And you really have to decide, how many, every time you ask the user to sign something, the customer to sign something, it might require them to reach in their pocket or their closet, pull this thing out, type a password in, like every time. This could be a really painful process. And intentionally, because these applications are designed to handle dollars, hundreds of dollars, millions of dollars, billions of dollars. They all use the same architecture. So the same software runs for $1 transactions and billion-dollar transactions. And that's what you got to be prepared for. Also, when you design your application, you might not know if it's a $1 transaction or a $1 million transaction. The pictures of cats, the pictures of apes, they started out as $10, $20, $100, and now they're going for $250,000. And the application doesn't change. Oh, PS, you can't upgrade these applications. So once you deploy them, it's permanent on-chain. So you got to design for the long term. So how exactly does the data indexer work? This is called data infrastructure. So you have raw logs come in from the chain, and this is whatever format you get them in. This is based on your smart contract developer, your on-chain smart contracts. They come in some format, and then you typically want to have one database specifically for the raw logs. If anybody who's done an ETL workflow, actually that's a question I have for Slack. So if you're on Slack, have you done an ETL workflow, and what stack did you use for that? Please tell me. I'll look at that in a minute. If you've done an ETL, extract, transform, load. They're different things. So the extraction, that's the one database. You want to have a data lake or whatever you call that in your data warehouse where the data comes in and it stays the same. Also, remember how I told you that it's eventually correct? The data that's coming in might be wrong. So you got a couple solutions here. One is you can buffer it. You could just wait 15 minutes on a 15-minute delay. So you probably can trust your data coming in. But even with a 15-minute delay, once in a while, you might get a transaction that has to be rewritten. So you got to be prepared for this. That's why you want to have a separate database for incoming data, because you might have to run a refresh immediately. Like you might get a phone, I might call you and be like, you got to refresh your data, it's wrong. And have fun with that. So you got to have a button for that, refreshing your data. And that can't be starting from zero and reloading everything, because you'll go over your bandwidth limit. There's too much data out there. And PS, everybody else is doing this at the same time. So you don't want to be stuck like that. So the raw data comes in, and if you have a reorg, you check your audit trail, you rerun it, and that comes in the raw logs. Second, you have the application logs, and these you can refresh at any time. So you can totally wipe out, you can truncate your app log database and rerun it from your raw logs. This is going to be your business logics in here. Like the raw logs might be like, you have a token. Token transfers from A to B. Token transfers from B to C. Token transfers from C to D. Okay, that's raw logs. Application log might include such information as who held the token the longest. That's not something you can query the blockchain for. You can't query the raw logs for who owned this token the longest. You'd have to manually check every single one of these, run an index, assuming SQL, or NoSQL is fine. You have some type of indexing mechanism, whether it's SQL or not, and you put this stuff somewhere that you can touch it quickly, if that's something you care about. If you care about the most popular tokens or the most recent or whatever, some type of a ranking, you want to have a live record of that so you can get this data quickly in the format you like. Oh, and PS, at any time, you might have to refresh this from scratch. So you truncate it, your application goes down, hopefully for a few seconds. You don't even tell people, it's just the page loads slow for a few seconds while you're quickly refreshing it. So this is something you definitely want to have hot spares. You want to be doing this stuff. You want to be testing this. This is totally not something you might be used to. And then obviously at the end you have API, which is some type of a REST or whatever API, or going directly as PostScript to your printer in some base. And these logs are going to, the logs and databases that you have, your business knowledge, will be queried in some way. And obviously you want to have indexes or some fast way to access this information immediately. Also, something else specific about blockchain is trust. Where does the trust come from? Who is responsible for these transactions? How do we know who we're talking to? So just comparing this to a few different realms, how do we know that the email is working? When we send an email, how do we know email is going to the right people? Well, usually we don't care about that as the email users, but as system designers, this is something we do care about, because when you stop caring, you get phished. And so the answer is we use DNS. If DNS is secure and the DNS has the records in there telling us which servers are to be trusted, then DNS will tell us which email is, where the email is supposed to go, and if it's secure, if it's the right email, if there's forgery, if it requires scrutiny. Not everybody uses DNS, the TLS based security for email. Not everybody uses it, but it's in there. For the web, how do we know that the websites are secure? Basically, we all use HTTPS now because Google was deranking you on search results if you didn't. And the way that works is certificate of authorities. So there's some type of an authority that we trust that's built into your browser, or your company installs it on your device. And then that tells you some type of a certificate. And then there's an intermediary certificate, and that signs some type of a key that connects you to whatever web application. Blockchain uses a slightly different thing. It also uses public key infrastructure. So there'll be a public key and a private key. And so as things are deployed, they're deployed on the identity of some public key. So the public key of all the actors is known. And the private key is kept secret. And the private key can be used to demonstrate ownership. So they can prove ownership of their account with their private key. So this is nice because it's very easy for anybody to validate something. You don't need to register. Every time you're acting, you're walking around, you're leaving breadcrumbs with your public key. So you can do something now, and then you can come back 10 years from now, and we know it's you. You don't have to prove any of the, you don't have to prove that it's still you. You don't have to prove any supply chain here. We saw you before, we see you again, it's the same person. This is the same as a PGP, same idea. And PGP also works inside of email. Very few people use that. That's not what I'm talking about for email. I'm talking about the email server, not the client. Yeah, so that is the way that trust works. Okay, so overall, what we've reviewed today is what is blockchain and the different concepts, contexts that you might be using it for an enterprise application. How are you going to make different pieces of your architecture connect? And then just some basic ideas for street smarts on designing your system so that you understand who's trusting who and not making a terrible application before you even start. Here's me. So here's a QR code from my website. It's also in the Slack. And hit me up on Twitter. I also have a community service hour in an hour from now, every single week, every Tuesday at 6 Philadelphia time, where I just take questions left and right. Obviously, I do a consulting and advisory on other stuff, but I do have a free hour every week because there's a lot of teaching. I have a lot of teaching to do, and I don't want to limit that to people that want to pay. All right, so questions, what do we got? Lay it on me.
Yeah, I was say if anyone has any questions and you rather type them in room C, I can gladly read those out. Or if you also just want to ask them, feel free to. I'm sure I actually have a few questions. That was
raise your hand, put on the microphone. Don't be shy. I'm going to pull up the Slack real fast.
So in the beginning, you kind of mentioned how, like, you know, there's been times where you've built out applications using blockchain technologies that you felt like, you know, didn't really need them. Like, what is an example of an application where you think that, you know, either it could only be done using blockchain technologies, or that it's that it really makes sense?
Every one of them. Every one of
Okay.
them does not use blockchain. So I'll just tell you how. So for government of Quintana Roo, which is they got the second biggest airport in Mexico, and they were doing these things. So to say from a technology perspective, they didn't really need blockchain. The problem they have is there's fraud. People were copying their COVID certificates, and the fraud was pervasive because the certificates are expensive and you couldn't work without them, and they were expensive and the wages are lower, so they're super expensive comparatively. So the risk for fraud is very high. And the fraud was kind of like the US, where people just scratch it out and write it in. And it was also inside fraud, where people, like the operator would make it. And there's also the operator would edit the certificate. And so there's a lot of different levels of fraud. And that's a problem. And so the government wanted to have some type of a security. There's a lot of ways you can solve this problem. So the different states in the US, they have solved this by having a registry of COVID results. Not a lot of people use that. The US also has something where there's a public key cryptography, where they have certificate authorities, and it's signed off by the state of California, who signs off on CVS, and CVS gives you a certificate, which you can trace back to the state. That works too. Perfectly fine. But the state of Quintana Roo said, we want to use NFTs for this. And I told them no 3 times. And then they said they want it 4 times, so we did it. But there's a benefit too. The benefit was it got greenlit for funding. It got press coverage, which is really important to Quintana Roo because that's a tourism state. And they had some people dying from COVID with fake test results. And so they really had a PR problem. And so the PR problem was people were dying, but then the PR positive was they're solving this with NFTs. So that was a news story that got a lot of coverage. So technically it works without NFTs, but some of the magic and the press coverage is actually real. FOMO is a real thing. So that actually helped their tourism by raising awareness.
Oh, that's really cool. I apologize if I mispronounce your name. Abid asked, her blockchain transactions are faster, but why are they eventually correct? Can they be real time?
Yeah, so if you're using Ethereum, it's just a few seconds to go through, but it's something called a reorganization. So there can be one block where the transaction, remember the network's multiple people competing on this huge lottery for a lot of money to make a block. So we say solving Sudoku puzzles, right? So they're all fighting to solve these Sudoku puzzles, and one of them will come out with it. But sometimes 2 of them will come out with it at the same time. And so what that means is on person A's block, your transaction came first. And on the other person, your transaction came second. That's a huge difference, because your transaction coming first or second might be the difference between you having the money and you not having the money before you send it, which means you either sent the money or it bounced, it fizzled. So the one could settle, but the other one might not settle for another 15 seconds. So now you have to make a decision. Well, which one counts? And so there's a negotiation process. So you might think that the transaction settles in 15 seconds. The UI might tell you your transaction settled. It might show your account balance. You had 2,000, you now have 5,000, but it's a lie. It's pending, everything's pending. So 15 seconds later, I've seen it. It's like 5,000, 2,000. It just jumps back. So depending, if you're trying to screw somebody, if you're making 2 transactions where you've only got 2,000 and you send it to one person and you send it to a second person at the same time, you're trying to do something tricky like that, yeah, one of them might go through, one of them might not. But if you're doing normal stuff, like you have it, you send it to one place and you're not doing anything fancy or dependent on that, then very likely 15 seconds from now, it's not going to matter. It's not going to revert or jump or anything weird like that. Also, if you're dealing with banks that move very slowly, they hold your money, then they give it to you. They're not doing anything fancy or weird like that. But it's possible. These things are possible. And there are scammers out there that will try to, overdraft their checks like that. So yes, your transactions might appear like they're going very quickly, especially on other networks, but they might not be as final as the interface is showing to you.
Abbott
And
also asked
the application has got to be, you got to think of that. So you as a customer, you understand that, but if you're building these things, you better understand that straight up and down. Because you don't want to take your application offline because something unexpected happens and everybody's account balance is wrong.
Abbott also
What's up,
asked,
DC? What's up, Indiana? What's up, Miami?
there are so many
Sorry, go ahead.
cryptocurrencies out there, and a lot of people are paying money to own them. And you said they'll be zero eventually. What makes you say that?
They're worth zero. Well, we're in Philly, so we've had some droughts here before, if you remember, where there's a drought and you can't water your car. Does anybody remember that? You notice about, hey, there's a big drought, and you watch TV. Back when we watched TV, it's like you can't water your car right now. They'll fine you because we don't have enough water right now. More so in California. Guess what we don't have a lot of right now? Energy. Energy and carbon pollution is a major concern. And so we want to limit the amount of energy we're using. And we've got this whole Russia thing, PS. And the whole reason that there's war in Russia is because Germans are using Russian oil. The easiest way to reduce energy consumption is to ban Bitcoin. That'll just wipe off 1% of the Earth's energy consumption. And China has done it already. So China makes decisions quickly and smart. They don't have two parties or anything to slow them down. So when China realized that Bitcoin's bad for them, they just turned it off. It's illegal. The rest of the world eventually will realize that using electricity for 1% of the Earth to solve Sudoku puzzles is not the best use of resources. And maybe they only make it, sometimes, like, hey, if there's a war in Russia, we're going to make Bitcoin illegal because we want to reduce our energy consumption and we want Germans to stop funding the war in Ukraine by buying all this oil. So I know this sounds a little ridiculous, and it was harder for me to explain this before the war, but now it just makes perfect sense. The war is directly killing people, so Bitcoin is directly killing people because Bitcoin is using the same oil for electricity that they're pulling out of the ground in Russia to send to Germany. It's the same oil. The market's fungible. So you're either using the oil or you're not.
Oh, thank you. Let's see if there's
this is not financial advice. This is not a prediction. This is simply an idea of where regulation might go.
Let's see if there's any more. We'll give it like another second here or so to see if there's any more questions that come up. I feel like I even have a million, but.
Oh yeah, ECL, healthcare provider data. Yeah, thanks, Tim. Yeah, that's special too because you've got different. You got firewalls in that data. You've got privacy involved. I'm even talking about public data. You're talking about private data, really private data. S3 Lambda. Yeah.
I actually do have another question. When you implement these systems, do you have some favorite like open source library? I mean, I've briefly kind of worked with Hyperledger Fabric in some of those, but outside of that, I really haven't done much in development.
Yeah, so you can use Burrow or whatever Fabric. Basically, they're all the same. They're all the same concept. There's going to be some database. In the database, you connect to it in different ways. Now, for anything that's like Hyperledger Burrow or more Ethereum-based stuff, we use a library called Ethers, ethers.js. I'll type that into Slack. And this is a front-end and back-end node application. So you can run it in the browser in JavaScript, or you can run it on the back-end as part of your indexer. And so as data is coming into the chain, you want to query it somehow. That's the best maintained library. But these applications are very simple. In fact, they're more simple because you're doing less processing. More processing is happening always towards the edge. We're always doing processing towards the edge. So you're running JavaScript locally, and it happens to be JavaScript is a favorite in this community, but you're running JavaScript on the server. The same exact JavaScript is running in the client. So you're fetching from the chain, they're fetching from the chain, you're processing it in the same way. And Ethers is the best library for this. It's just a library. In terms of frameworks, people are using a lot of frameworks. It happens to be Node is very popular, but you can run Lambdas and S3 for your content management too.
Awesome. Thank you so much. I was going to say, if there's no more questions, we can wrap it up now. Thank you so much, William.
Cool.
This was very interesting.
Thank you. Have a good day, everyone.